Modern enterprises are suffocating under an immense cognitive load. Today's organizations generate unmanageable volumes of fragmented data across entirely disconnected systems. For decades, companies have relied on rigid legacy databases like AppFolio to store this information. These systems were built to be passive ledgers, requiring human operators to manually input, search, and interpret every line of data. Because this information is trapped in static repositories, these databases act as anchors. They slow down decision-making speed and erode institutional agility, turning vital historical wisdom into inaccessible archives. The result of this fragmentation is continuous organizational noise. Executive teams are fed delayed, incomplete signals, locking the C-suite into a reactive posture where they are constantly fighting fires instead of directing strategy. Surviving this complexity requires a complete departure from the fossilized filing cabinet model. Organizations must deploy systems that actively perceive, synthesize, and respond to incoming data. The solution is the implementation of a proprietary framework known as biodigital architecture. This architecture functions as a bidirectional digital nervous system. It pairs human biological intuition, specifically the digitized heuristics of executive decision-making, with industrial-scale artificial intelligence. Adopting this framework moves an enterprise away from labor-intensive service models. Instead, the company deploys cognitive augmentation, turning its own internal data workflows into a defensible intellectual property moat. The Echelon portfolio demonstrates how this operates. We see a vast categorized index of market-hardened intellectual property, proving this architecture is a deployed reality. While these digital frameworks address different industries, they are interoperable, driven by the exact same overarching architectural philosophy. The ultimate objective of this ecosystem is to construct a strictly governed neural architecture of trust. To successfully move operational risk off a corporate balance sheet, an enterprise AI system must operate with verifiable certainty, grounded entirely in the organization's historical wisdom. You cannot build a proactive AI system on top of fragmented, siloed data. The foundation requires strict centralization. The enterprise establishes its source of truth using Google BigQuery, a fully managed data warehouse designed to query massive datasets at high speeds. Pulling disparate data streams into this single platform eliminates fragmentation, providing the uncorrupted raw material AI agents need for verifiable accuracy. With the data centralized, the enterprise layers on its primary intelligence engine using Vertex AI. Vertex AI is Google's machine learning platform that allows developers to securely train and deploy custom AI models. These models undergo a strict hybrid training strategy. The first phase uses synthetic data to pre-train the system, establishing its core reasoning capabilities and teaching it to process complex business logic. In the second phase, the model is fine-tuned with real device data. This aligns the theoretical logic with the actual physical world operational nuances of the business. Google BigQuery supplies the curated historical fuel. Vertex AI processes that fuel to construct the complex reasoning engine required to operate at a global enterprise scale. Deploying generative AI in high-stakes environments introduces a severe trust problem. Unchecked models prioritize generating a fluent answer over generating an accurate one. Off-the-shelf AI relies on general knowledge from its initial training set. Without specific guardrails, these models inevitably produce outdated information and hallucinations. To solve this, the architecture utilizes retrieval-augmented generation, or RAG, forcing a model to pull facts from a verified database before generating text. The green pathway demonstrates how RAG strictly enforces grounding, prohibiting generic inference and fetching specific truth from BigQuery first. Standard AI is static and restricted to text. RAG facilitates multimodal applications, allowing it to process incoming text, live inventory data, and real-world telemetry simultaneously. By eliminating hallucinations, RAG transforms volatile AI potential into a legally defensible, industry-specific intelligence engine. A digital nervous system must perceive and respond to the physical world at the operational edge. Organizations achieve this by using orchestration tools like Make.com and Notion. These platforms act as the connective tissue, replacing manual site communication with automated logic.
These tools construct bespoke ingestion pipelines. They take unstructured field data and funnel it directly into the company's structured institutional memory. We see this architecture deployed in the marine retail sector with the accelerating C Pro sales engine. This system integrates a live React framework with external NADA valuation APIs. React provides the user interface, while APIs are the bridges allowing distinct systems to exchange data in real time. By connecting these systems, the sales team receives instant margin calculations and high-fidelity product narratives, accelerating maritime transactions with verifiable data points. The same structural logic operates the Building Intelligence Framework, deployed for Fager-McGee commercial construction. Here, the bidirectional pipeline monitors the chaotic environment of a physical job site and pulls that real-world telemetry directly into the executive office. It replaces manual oversight with real-time safety compliance monitoring and automated bidding analysis. In both retail and construction, the biodigital architecture actively protects corporate margins. It ingests raw environmental data and outputs actionable executive certainty. The ultimate purpose of this technical blueprint is to generate high-fidelity digital twins of the entire enterprise. Digital twins are digitized manifestations of executive intuition and decision-making. These mathematical models allow the C-suite to simulate the organizational impact of a strategy before it ever touches the physical world. With a high-fidelity simulation, leaders can trial complex strategic maneuvers in a digital sandbox. They validate the outcomes risk-free before a single dollar moves on the corporate balance sheet. The versatility of this architecture scales to the extreme limits of computation with the alpha-qubit quantum error decoding asset. Alpha-qubit utilizes a recurrent transformer architecture, a deep learning model that retains memory of previous data sequences. By using these transformers to decode the subatomic noise on Google's Sycamore processor, the system isolates high-fidelity signals from physical entropy. This is the same technical mechanism used to filter signal from the noise of a chaotic construction site. Whether optimizing a global supply chain or unlocking quantum hardware utility, the underlying architecture acts as a universal, verifiable filter for mastering complexity. The technical capability of this blueprint directly dictates a new strategic monetization roadmap. Forward-thinking organizations are moving away from competing on labor-intensive service models. The objective is to package this precise blend of historical wisdom and biodigital engineering and license it as high-value intellectual property. Licensees are purchasing the acquisition of a superior cognitive moat. This allows an organization to price its offerings based on the elimination of strategic uncertainty rather than hours of labor. To survive modern market volatility, leadership must fully commit to the digital twin decision-making model. By grounding every operation in the neural architecture of trust, enterprises cease to be the reactive victims of legacy systems. They become the true architects of certainty.